Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 406, queue reconstruction by height. This is a medium difficulty Leetcode problem, and the problem description tells us that we're given an array of people called people, which are the attributes of some people in a queue. And we're basically told that for each element in this people's list, it's a height and n, which is a number, height and n, and basically n is equal to how many people in front of this person has this height before them. We want to reconstruct a queue. We want to reconstruct and return the queue that is represented by the input array people. And so basically this reconstructed list should basically just be the correct order of this people's list that we are given. So in this example, we're given a list of people. You can see the orders are all jumbled up. Here is a correct order. So we see, the first element has got a height of 5. No one before this first element exists, obviously. So 0 is the number of people taller or the same height. Same goes for 7. What about 5? Well, 5 has, person 2 has a height 5 with 2 people that are taller. So first element, element has an index 0 and element at index 1, and these two elements are greater than or equal to height than 5. So we add 2 to this. What about 6? Well, 6 only has one element or one height which is greater than it. So this person with height 6 has a superseded height by 7. So I hope that kind of makes sense. When we look at this 7, 1, there's only one other person, and that's at index 1 that has a height which is equal to 7. So we're basically given a list, and we want to make sure this list is now back in sorted order. How are we going to process this? Well, it can be a bit challenging to come up with, but this is a greedy and sorting problem. So this is a greedy problem. We want to be greedy when solving this problem, and kind of we want to split this into little bite-sized pieces. Let's look at these two elements, 5, 0 and 7, 0. So we've got 5, 0, 5, 0, and we have 7, 0. Well, why is it in this order? Well, let's say we had 7, 0, and then we had 5, 0. Why would this not work? Well, it wouldn't work because this element, is bigger. There's a height that comes before 5, which is 7, which is greater. So this really should be a 1, But so this wouldn't work. It has to be the other order. So, if we do 5, 0 and 7, 0, well, this is fine. So we can see that tall heights are not affected by short heights, but short heights are affected by tall heights. So we want to process tall people first because once they're placed, their k value can never be affected by the shorter people that are added later. Their k value will stay the same. It's the shorter people whose k value will change. So let's say we have let's go to another example. We have 5, 0, we have 7, 0, and let's say we have 6, 1, and now we want to process 5, 2. So we've processed the tallest heights first, and then after that we're the heights which have the if they're the same, basically we want to process the height which has a lower k value. So we want to process the k values in ascending order after we've got we process the tallest heights. And so where would we put 5, 2? Well, we would put 5, 2 at the index of k, because we've already processed all the heights which it relies on. So we can plop it right here, and we'll know that we've processed the correct amount of tall people first, and the correct amount of people which have a height equal to it first. So we can just insert it at the position, index, let's call this k. So we can just put it at index k, and it will be correct. So we've already processed the elements that come before it. And we'll do this for all the elements in our list. So this is kind of what we want to keep in mind. But really the core rule that we want to keep in mind is that we want to process tall people first. We want to process tall people first and not short people. tall people's k value stays the same, short people's does not. So we want to process this, we want to sort this list such that we have the tallest people first, and then if we have like 50 and 52, we'll pick the element which has the smaller k value, and in ascending order. Basically, if we have 53, so it'll basically just be in ascending order. So descending order for height and ascending order if the elements are the same, and then we will compare them with the k value. So I hope that logic kind of makes sense. Let's actually get to coding this problem. So first thing we want to do is sort our list, basically. So we'll use a lambda function, q lambda. I'm really bad with remembering the lambda functions for this, I will be honest. Let's say x is the element, so we want to do this in descending order, don't we? So minus x, actually I think we can do that. So minus x 0, and because we want to have another condition n, when the elements are the same, we want to compare them based on their k value in ascending order. So we can just put x1. So this will sort them how we want them to be sorted. The next thing we want to do is have a k. So we've got a list that we can now process, and all we have to do now is insert them at the index k. So we can say for each person in people, let's insert q.insert at position of the k value, at position k, let's insert this person, and then just return the q. So let's submit our code and let's check that actually works. Okay, and we see that all 36 test cases are passed for this problem. So I hope this video kind of made sense, guys. I hope the solution makes sense. It's a bit confusing, but once you understand that it's greedy, that we really want to go for the tallest first and then the shortest, that kind of logic makes a lot more sense in solving this problem. So in terms of time complexity, well, sorting is going to be big O of n log n. But remember, inserting into a queue, well, what does that give us? Well, that gives us, big O of n squared. So we're going to have a time complexity of big O of n squared. Space complexity is going to be big O of n, because we're creating a new queue. So constructing a new queue. So that's going to be big O of n. So big O of n squared time complexity, big O of n space complexity. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.